So the topic of today's discussion is modeling security policies. And before we jump to this, it seems like dry topic. I want to say I'm really glad to see you all here today. It's my first conference in so many years after we locked out. Thank you for coming. So this area of modeling security policies is very wide, as you could see. Devices range from embedded to very complex systems. The software ranges from embedded all the way to the enterprise system, right? And modeling security policy is a very knowledge-intensive area because it's an overlap of, first of all, system design. The second thing that comes to mind is the cybersecurity, right, that we have to address. And the last thing, but not least, modeling techniques. So you have to learn the tool to model something. In our presentation, we're going to show all the models and snippets and extracts based on UAF framework, and we used Cameo software to model policies. So we start with UAF constructs and go through policy definitions that we picked for this presentation in particular. And then we will talk more about the examples, how the security policies can be applied to various areas of enterprise software, ranging from some basic resources down to more complex services like VPC, latest in Amazon Cloud. So we used Amazon Cloud in one of the recent projects, so lots of examples come from that type of modeling activity. UAF specifications in the security viewpoints, they offer several very promising objects that can help us model security policies. The first one that comes to mind is security constraint. And you could see the definition that we borrowed from the UAF specifications version 1.2. So security constraint, as you can see here, specifies textual rules, non-functional requirements that are security constraints, right? And as you can see on the diagrams, security constraint can be applied to assets, processes, roles, various constructs derived from those base objects, right? So it seems very good fit into modeling security policies, right? Thinking of wide range of security policies. The second object that we may consider is security control. And you could see that UAF definition says management. It's a management, operational, and technical control that is supposed to help us with safeguarding our assets and building countermeasures, right? And the visuals provide a good explanation, really excellent explanation, how security controls can be applied. So all those relationships on the right-hand side, as you can see, they pertain to various objects that could be useful in our design of the system security. And the last one, which I picked on, is the resource mitigation, which is supposed to be a construct, a resource performer object that should help us address specific risks, right? And according to specification, resource mitigation derived from resource architecture. And you could see that resource mitigation can be connected to assets, right? Because it's asset itself. Could be connected to security controls. And question becomes, we have the whole variety of objects, so which one we're going to choose to implement our security policies, especially when we have to deal with wide range of security policies, perhaps ranging from ACLs or access control lists all the way to maybe more robust security policies that prescribe how software services should perform certain actions or operations. Anybody has any ideas, any preferences? All right. So we chose the security constraints for modeling a wide range of security policies. When it comes to the convenience of working with security constraints, we found that this type of objects have rich potential. They are wired correctly to all the other objects in UF framework. They may be lacking of certain features that would make them more convenient for software designers. And those constraints that these objects currently have in version 1.2, they would not allow us to build a robust hierarchy of security policies as an object structure. They do not have, full-fledged class capabilities. So no doubt when we looked at it from the security policy modeling standpoint, we thought, okay, we'll take it as a basis. We will start from controls, right, from the constraints, and then we'll build on top of it. So this list of AWS policy definitions, borrowed, of course, from the AWS documentation, they tell us what policies are that we're considering. AWS policies that are native to the cloud, AWS cloud, and they're managed by AWS, administered by AWS. As a software architects or enterprise architects, we can build custom managed policies, right? That would be suitable for specific use cases. And those policies that can include normal AWS constructs, accounts, groups, roles, other types of objects. Inline policies here created for specific identity, right? They live and die with that identity. Identity-based policies or resource-based policies, they're also important in this scope. And here is the reason why we talk about these particular policies. We need to think about information that these policies may carry, because that information is very impactful to our system design. Again, ranging from embedded software all the way to the enterprise software. So think of that information embedded in your policies and the impact it makes on the behavior of your systems. And some information elements are listed on the right-hand side, and it's probably not an exhaustive list. So when you look at region, right? When you look at region, the first thing that cloud architects think of is, cloud region. US East 1, US East 2, and so on and so forth. Amazon has its own regions, Azure has its own regions, and so on and so forth. But you could use the concept of region to define location where your software will be installed into. You could define region as a geographical region where your software will operate. So think of a global company that has affiliated branches or affiliated companies scattered around the globe, right? And then one of the regions owns the information. They author that information. They maintain that information. The other regions, geographical regions, may use that information, but they will have read-only access to it, right? That is the way how you would actually introduce geographical region into your software. And you could build policies that prescribe how to react to certain actions issued at specific geographical location. So you could build constraints based on that geographical region. I will probably jump cloud accounts and other obvious things all the way to API endpoints, because that is an interesting point as well. When software engineers build their services, microservices, they just focus on interfaces, right? The contracts, because that's where the software has to meet the requirements. But the security policies defined on endpoints can specify the name of the endpoint, right? The method that endpoint is supposed to invoke. You know those methods, right? Post, put, delete options, so on and so forth. So your security policies can be very granular on API endpoints. Some security policies may carry encryption keys or platform-specific information or conditions under which specific actions should be allowed to be executed, right? So the conditions are very powerful tool as well in that area. And if you are into microsegmentation, tag-based constructs, in that particular case, the attributes are not on the list, but you could use environment ID embedded in the policies and attached to various assets or even accounts as tags, right? You could use application name, you could use process name. So there's a lot of information elements that can be embedded in assets as well as security policies. And security policies can effectively verify all the information elements and either deny or allow specific actions. So we looked at the constraints that UF specification carries, and we like the idea, we like the way it's supposed to work in the design, in the model and design. And we thought, okay, clearly clouds may have managed policies, may have custom policies, open source software may have their own policies. Configuration policies come also with lots of software. Some software systems have constructs that are similar to roles, but they are not roles, right? Data zone declares that project can have members, can have viewers. I know some collaboration software may have various roles like contributors or casual users that have read-only role, right? Moderators also popular in collaboration software. So obviously those constructs may or may not be in the cloud. They may not be defined in IAM, right, as IAM role. And then you have to deal with the systems that may be not native to the cloud where they offered, right? Those systems that were ported to the cloud. And those systems, they existed for years. Some software existed for a quarter of a century. And they have their own rules, their own permissions, and you build their own groups of users, and you maintain your own accounts in those platforms, right? And all those software systems and platforms all of a sudden got installed into the cloud environment, right? They know virtually nothing. When they get ported first time, they know nothing about IAM. They don't support IAM roles. They don't understand IAM accounts. And oftentimes you have to come to those platforms and start managing those platforms, building user accounts, groups, permissions, issue grants, and all kinds of stuff that needs to be maintained. You know, perhaps the most popular database, right? And you could connect to that database via JDBC or RDBC, right? And you would actually use a user account that is created and maintained in that database. But you also have a native database that Amazon provided, Redshift, right? And that Redshift database can be open to an account maintained in IAM, and you could maintain permissions in IAM for that type of database. But that is a native cloud software, right? That's the difference. So when we built the whole hierarchy of objects representing our policies, we thought of that complexity, of course. And not all objects are treated equally here because we had our own focus, our own angle at it. So you could see access controls are maybe less important for us than resource-based policies. We kind of spend time verifying how the hierarchy should be built, where things flowing from the top to the bottom. And you could see the two objects were used as foundation for building any type of AWS policies. That's the UF rule and UF responsibility class. That's how we actually made our policy object more robust. Now our policy object can be visualized. It can be used to describe various attributes, information elements that you have seen on the page. We could use text. We could use object hierarchy and use specific base classes to define our security attributes, and more importantly, propagate those attributes across derived classes, right? So that's what you see here as a hierarchy of objects representing various policies. What about the open source software or components that were brought into Amazon services? For instance, EKS, Elastic Kubernetes Service. You could see Redify, which is an engine used in EKS to verify the image signatures. We modeled it outside of the AWS policies, and now Redify policy is a standalone object. It represents the configuration policy. You could see that data zone project membership at the top right-hand corner is modeled like that as well, because it has a unique set of roles, internal roles that are not typically exposed to IAM. And the Redshift permissions you could see here, they are included in quote-to-quote AWS managed policies, but you know, as a software of that complexity, at that level, it can be managed internally. You could create internal accounts and manage permissions and groups internally, so JDBC could have access to Redshift, or you could manage it on an IAM level. And the main emphasis here, when you come to modeling security policies, you don't have to obviously embrace the whole universe, right? Model what you're going to use. Put attributes in the base classes that you see in common, right? That all the objects derived from your base classes will be using. Think of your own needs and spend time where it actually delivers the value. Because obviously that's your model, that's your system design, and you have to secure your system using this type of objects. So think of usability of this type of thing. Now, quick question, really quick question. When it's time to design security policies, if you have a project larger system or smaller system. And your management or, your book tells you you have to secure your system, right? So when it's time to design security policies attached to your assets, to your software assets, first option, okay, we'll figure out the security policies before we come to information security review. Sounds familiar? So we do the design, we do the model, we design interfaces, we design systems, and the security policies will be designed later because our security review tells us the software has to be secured, right? That doesn't sound right. The second option is we will design our assets and interfaces and contracts will be satisfied, and we will do our due diligence with all the cross-references between requirements and assets. And as we go along this process, we will define deployment of our software, right? Because the requirements tell us this piece of software has to be deployed across 2 or 3 data centers, and each data center has its own infrastructure and so on and so forth. So when the DevSecOps guys come over, those engineers, and we'll talk to them, we will figure out the security policies, right? Oh, doesn't sound right either. If we look at the name of this conference, Secure Software by Design, the answer is right there. You have to design your security policies along with the assets and their interfaces and interactions. And if you do it at the top level, as the UF specification prescribes, on the operational level, that's very easy. You drop a box, operational constraint box. You would say, well, here is my policy. This object is available in read-only mode to this type of users or performers. When it comes to the resource level, that's where the solution architecture comes to play, right? You start tinkering with all those constructs, open source software, native cloud software, ported software, current state, future state. By the time when design is complete, maybe something will be available, and you'll have to start thinking of all those security policies around all the objects that you design in your system and their interactions and the user interactions with those systems as well. So when we came to this type of questions, we started paying attention to the way the platforms and applications manage access and manage the roles for their users and manage communication amongst themselves. We found an interesting, like I described, interesting constructs in the most recent data zone software. We found an interesting security policies in data catalogs, because data catalogs are typically like Amazon Glue. Data catalog sits between your data source and the data zone as a tool for publication of your data. And there are some ways to collect information and metadata and not only harvest that information, but also pass it to the end user. So all that activity is governed by Amazon Glue security policies and permissions. An interesting topic is about the databases, because that is a different universe. Databases existed for many years, and many databases are tightly integrated into their native clouds. But then what if you have to use Oracle in Amazon? What if you have to use Microsoft SQL Server in Amazon? What if you need Redshift and your software may exist elsewhere, on premises, for instance? So that that construct of internal user accounts, groups, and roles is very interesting. Open source, I think new offerings pop up every day, every week. Open source communities work real hard, and those tools, they deserve special attention when it comes to managing information through their interfaces. And overall, if you look at applications and platforms, before you even start designing security policies, it's very useful to assess, is it certified for maintaining PCI or PII? Is it HIPAA compliant? Does it have all the bells and whistles to secure your information and workflow? So the first thing that we go into talk about here and in examples as well is the resource-based policies, and good examples of those resource-based policies are attached to S3 buckets. Everybody knows that you could get input objects, Lambda functions that you could execute supposedly serverlessly, that's the word. Resource-based policies can be attached to KMS services managing keys, and of course endpoints. Modeling all the resource-based policies for deployment is an interesting topic as well, because when you start modeling your policies, they may depend on the environment where they applied. And in the modeling software and specifications, the capability configuration objects is the focal point where you collect user role, piece of software, possibly system specification, right? And that's the place where you could attach specific policies that might be unique to your deployment, right? Configuration objects, don't miss that one. A little discussion about attributes and tags. As you design your assets, you'll see that policies allow you to define attributes and tags. And those attributes can be virtually anything you want to emphasize. Actions, conditions, resource ID, anything that you can think of. You just have to model that. Flatten out your security policies that you use in the field, put the most important attributes in the model, and that will serve as a reminder to application, app dev teams, and solution architects that will come after you. And obviously, they will use that information. Tags could be widely used if you're planning to use the tag-based rules, and they will be available in those objects that we have seen in the custom profile. So let's take a look at the platform realm and their permissions. Interestingly enough, platforms may use your cloud principles. They may have their own cloud, their own principles, right? Security principles. You have to pay attention when you design those policies, what kind of user you're talking about, and what kind of policies you would apply. If it's a customer-managed policy, perhaps it will address certain concerns on the principles embedded and maintained in your platforms. The attributes in that case that you would put in the policies, they may be just very distilled information describing the effect, the actions, that's an array, list of actions, and all the other attributes that might be specifying your platform. You could go as granular as a process or workload specification. And those bits and pieces of information will become available to you as you work through system design with analysts and architects passing that information. So if we look at the model at the top, right, that large blue box, you could see that structure that we have, the data structure that we have defined in that policy, custom identity-based policy. It matches the script. It matches the script that actually your DevSecOps team will put together to implement specific policy. All the elements are there. And that's just a proof that basically you could model pretty much anything. And the granularity level can be very low. And you could use technical language if you have to. You don't have to, but if you have to, right, you could use it. You could define actions. You can define the other attributes in natural language. But if you have to project script into your model, yes, you could do that. Ratify, as I said, used to verify signatures on image on the container images. And I will not go into details. If you're interested in the ways how Ratify is built and what it does, you could read that. They have very good manual on the web. But Ratify policies prescribe which type of verifier is used, either cosign or notation, right? It actually shows the key, the path to the key that was used to sign, or pair of keys that were used to sign the image. So this type of policy is a configuration policy that you could also model, right? And you could see the connectivity between the utilities working behind EKS that is also defined in there. So the model becomes really precise in terms of your intentions, what you're trying to do and what you allow or not. S3 and ECR policies are very basic in this case. As you can see here, policy may actually demand an encryption on S3 bucket, right? And that encryption can be either AMS or server-side encryption. So you could see this little script that actually says, that's a condition. The bucket can accept a new object if the encryption is provided, right? ECR policies may drive access to the repository and images. And you have to pay attention to, in this type of modeling activities, if tags are supported by real software. Because sometimes tags may not be supported in the conditions. If you model it that way in your security policies, when it comes to real implementation, people will come back to you with questions. So you could see that S3 bucket work is incomplete. We will not go through an exercise to finish that definition today, but just that action is specified there, resource is specified. It's incomplete, so there's some work left. Perhaps next time we will do something like that. ECR policy is here in the lower left-hand corner that specifies actions, principle, and effect that allows services to pull or EKS to pull specific image from repository, from the registry. Secret management, this is very basic policies that we pulled from Amazon scripts. They prescribe how you would actually access, or if access is allowed, and you would actually read specific secrets from secret manager in case if you have to. If you need to enable encryption on EC2 and EBS volume, right? You could pull those policies into your model as well. And you could see 3 different policies here that actually prescribe very specific actions that we modeled here. And resource, just if you look at this, resource can be wide open. A list of resources is wide open here, or it can be very precise. You could specify the key, for instance, using R. So that's the benefit. If you look at more complex policies, like VPC Lattice has policies prescribing how the services communicate to each other. So they would collaborate in specific workloads. You could see that various actions are defined and conditions, more importantly, very robust conditions are defined. And you could see the resources are important in this case because the resources describe what type of services can talk to each other, right? So VPC would create that network-defined, software-defined network, and the services would actually play with each other. So in this case, the knowledge base can be queried, and CMDB can be queried from another service. All right, we will probably finish because the time is up. Any questions?
Thank you. My question to you is, how does this work when you have a multi-cloud environment so that you've got Azure and AWS? Is it done at a resource-based policy level, or is it at the platform-specific permissions? It's confusing to me.
Mm-hmm. When you design your policies at the operational level, the implementation of that platform or information about the platform is immaterial, right? You would just say, here is my performer, and I want that performer to have access, read-only or read-write access to a specific resource, right? Because that's the level of abstraction. It allows you to ignore the complexity of the software implementation. When it comes to resources, in that particular case, you have to define the resource as a system implementing specific services. And that resource, let's say the service is of DBMS, just making this up for an example. It's a DBMS, a very generic system. Then you have a piece of software that is, in our case, was Redshift, for instance, right? And that Redshift has schema, it has tables, and those grants on the schema and tables are specific to your schema in that particular database, right? You may say, well, I'm going to use Oracle as well, maybe in a different region because Redshift is not available. Or maybe it's financially not practical to have Redshift, right? In that particular case, schema name, table name will remain the same because that's your database design. Account ID internally existing in the database will remain the same. How about the names of the specific permissions? Those permissions can be different. So when it comes up to all the way to the custom profile, you have the AWS policy, AWS managed policy, right? And then Redshift permission over there. The chances are you will have Oracle policy, an Oracle managed policy, an Oracle DBMS permission over there as well, if you have to embrace that type of variety of various platforms, right? So when you design your system, you start from the top, usually, unless you reverse engineer something. And then you gradually go down to the lowest level. That's where the discrepancy will happen. And then you would have to, your profile would have to embrace various types of policies. Well, some systems may not be as graceful as a world of databases because the databases have all the user accounts, typically permissions, grants, and so on and so forth. They have to be compliant with whatever that SQL standard is, right? So that universe is more ordered. Now, you may have some unique pieces of software where platforms, they get creative. People get creative. They build new software, right, which does not follow any standards. You could see like Wikipedia, 10 different implementations of Wikipedia, right? And those permissions and policies could be different in each and every implementation of Wiki. In that particular case, you may have to build unique objects to reflect those policies that are unique to your corresponding system.